everybody. If you can hear my voice, then that's a good thing. That means this is working, and it also means that it is time for chemistry. Yay. Oh, hold on. My audio is peaking. I need to turn me down slightly. There we go. And then I need to put the chat in the front so I can actually read it. Hi, everybody. I will try and be as less stressful as I can. Our class is kind of packed with a lot of information that we need to go through. So we might as well get started with that. But I mean, like, I try to be pretty mellow about this because I realize, like, yeah, you know, there's still a pandemic going on after 2 years. All right, so hi, my name is Wes Hillman. My degree is in inorganic chemistry, which is basically what this is. General chemistry is all your inorganic stuff. OChem is your 131. I do teach that too. Maybe I'll see you there after this one. Please address me as any of the following. I like just the first name basis that I have going with, I mean, because I call you guys by your first names because that's what's on my roster. So you can just call me Wes, that's fine. You can also address me as professor. I like the title professor, even though formally it's not what I am. I'm technically just faculty. I did have a student call me boss one quarter, and I was like, I'm going to add that to the list. I like that. And then I'm a huge nerd, and orcs are my jam, so any derivative of orc that you want. Just don't call me Mr. Hillman. It does make me feel old. Pretty soon I'm just going to have to face the music, I guess, about that. I'm 38 now. Will you need the textbook before Thursday? No. I don't formally assign homework. We're going to talk about that in a second when we go over the syllabus. The textbook is primarily for extra exercises for you to do, and also another source for you to read the course content. The ideal strategy which we'll get to in a second here, is you read it from the textbook first, and then you come to lecture and then ask me questions about anything that's unclear. You're going to find out that this is a class that is entirely based on time. Just like any skill really in life, the more time that you put in from different angles, the better you'll get at this. And the textbook is there to aid you in that. Could you do without the textbook? Technically, yes, but I wouldn't recommend it because it's actually a decent textbook, and having extra exercises is useful. And yeah, I did say orc. It's right there on the screen. Orc, right there. Let's see here. I have my email on the screen right there, whillman@everettcc.edu. I put that on this slide so that if you write it down, and you need to contact me for any reason, but Canvas isn't working, for example. Like, sometimes Canvas is down, so you can't email me through that. Or it's like the first day of the quarter, and Canvas is jam-packed, and like, I've had issues where Canvas has like not sent out an announcement or an email or something that I told it to for like up to 2 hours or something, because it was just overwhelmed on the first few days of the quarter. There are reasons to want to directly email me from a different service than Canvas, and if you don't have my email address, you can't do that. So there it is. You could also look it up in the faculty directory. Do I have other fantasy names? Yes, tons of them. But that's beyond the scope of this class. So, all right, how do you get a hold of me if you have questions? So email is one way. I still need somebody to make the class Discord. That hasn't happened yet. But I conduct office hours through Discord, in the sense that, like, once the Discord channel is open, you can then ping me at any time that you want to with a question. And if I'm at my computer and I hear it, I will answer it immediately. And if I'm not at my computer, I will get to it when I come back. As soon as I said that, I went and checked the class Discord for my other class to see if there were people who had messaged me, and there had not been. So I was like, oh crap, I forgot to do that. So I will do my best to try and answer all questions through Discord. I do have it up on my computer at all times. So that's just the medium that I've referred to. Yeah, I have not gotten a volunteer for this specific class. I've had one for a different class. So if you are interested in doing that, send me an email with an invitation link, because I'm just going to say that you're the first one. Send me an invitation link that doesn't expire and has infinite uses. Send it by email. You can't post it in the chat because it'll get filtered out. I will get that set up after class later tonight, and then I will post it once I've vetted it that it is indeed what I want. Okay, so I don't actually know how many people are first-time students in Chem 121 because this is a first course for some people. And so what I like to do on the first day is I like to introduce you to what Canvas is and does. Why is my cursor not? Oh, there we go. That's why. So what Canvas is and does and how to log in. So if you click on this link here, you actually can't click on this because it'll just pause the video. But if you type this into your browser bar in a new tab, you will get a window. And I got to move this window so that I can actually see the window. There we go. So you'll get something that looks kind of like this. You'll have a bunch of windows in here for all of your courses. I have tons of courses because I teach all the courses. And so here's us. We're right here. One of these two. I have them color-coded. So I'm going to click on 39981. They're the same whether you're in 39981 or 39983. And then the first thing you want to do is go over to the tab that says Modules. And hopefully you have already done this, but there's a bunch of information on this page. Some of it you can't see, so you can't see the study guides yet or these links because we haven't had a lecture yet, and we don't have a class Discord invite. I just realized that part of this is cut off here. So I'm going to kind of cover the chat for a second here. So you followed this link to get to my page so that you could watch this video. Here's the syllabus. Hopefully you have already read the syllabus by now, or at least looked over it. And then, at some point, you need to take this quiz. So the orientation quiz is a series of questions that ask you to, 1, look through the syllabus, 2, look through my YouTube page, and then 3, just general stuff about like Canvas and how it functions. You do need to get 100% on that. If you don't get 100%, it keeps you locked out of all the materials. Once you do get 100%, it should open up everything. If it did not, I had an issue where a student emailed me and, hey, it didn't open all my stuff, so I fixed it. And it should be working now, but if it's not, let me know. And then once you've done that, here are all the slides. So these are just per page, 3 per page, and then 6 per page, depending on what flavor of slides you like. And then all the lab content is down here. And then finally, I have a bunch of worksheets and worksheet keys for practice problems. So since we're doing chapter 1 this week, these are the problems you should practice before the quiz, for example. If you click on the syllabus, you'll get to the document that I'm going to go over. It will load right here, but what I'm actually going to do is I'm going to get rid of this. And then I'm going to open up... where is it? Did I close it? No, there it is right there. It just didn't find it. Adobe, there we go. We'll put this one on the screen. All right, there we go. So I'll just put this on the screen. So let's talk about what you have got yourselves into with Chem 121 here. So Chem 121 is a nursing/allied health course. It is a basic fundamental chemistry background survey course that provides you with the foundational skills that you'll need for Bio 211. If you are planning to do nursing or dental hygiene, things like along those lines, then you're going to be required to take a bunch of bio courses, and the prerequisite for those that sequence is Chem 121. So this is the first step. We're going to give you the information that you need to understand all of the stuff in cell bio, and whatever comes after that, because I don't know the bio sequence that well. On the screen, I have the schedule. Anything that is on the far right column is a due date or a thing that you need to do. You'll notice that not every week has that. So for the first week, things that were due on so there was something due on Sunday. It was go to the test stream. Some people did that. You watched me flounder around, play Mario, and finish it in like 46 minutes. That wasn't graded, but it was just a thing that was an event, so I put it in blue. On Friday, your orientation quiz is due. So if you have not completed the orientation quiz by then, I drop you from the class because I assume that you aren't um, intending to stay enrolled if you haven't done the orientation by then. If you can't do it by then, but you intend to stay enrolled, please email me as soon as possible so I don't drop you mistakenly. And then after that, it's just going to be the due dates for worksheets. We do have 2 exams there in the middle of the quarter, and then at the end of the quarter, and then right after that is the final. And then other than that, on this schedule is just a list of like how we're going to go through the chapters. So we're going to do about a chapter a week. Some chapters are longer or shorter than others, so they take up more time. And I've spread them throughout the quarter based on about where I think we will be. We'll try to keep to the schedule the best that we can. And then page 2 is just everything you care about. How many points do you need to pass the class? You need this many points. Oops, that didn't quite work, but if you're aiming for a C, you need 370 points. There are 515 available. If you want an A, you need 473 points. So, big difference there. What are the things I will grade you on? There are 9 quizzes, 1 for each chapter. The last chapter does not have a quiz because there's just no time. There are 2 exams. Each exam is worth 75 points. There are 5 laboratory assignments. Each is worth 25. And the final itself is worth 150. So, sum it all together, you get 515. Your total points divided by the total points possible is your grade. Very simple. I don't weight anything. I don't curve anything. You always know what your score is. Canvas will try to calculate your grade. It may try and make predictions based on things that aren't visible or there or other issues. Like, I don't actually tell Canvas to input all of your scores for a specific reason because of how Canvas works. So it may give you erroneous data. If you don't trust it, just calculate your grade manually using that sort of formula. And then finally, here are a bunch of links that you may or may not find helpful. The first link is just a link to the student handbook that is basically saying things like don't cheat, don't be an ass, stuff like that. If you ever have trouble with Canvas and you need to get a hold of somebody, email this email right here, elearning@everettcc.edu. Hannah and Mary, I forget what her name is. Marianne? I'm not sure. I just type hi e-learning, but like they solve everything for me. Hey, this isn't working. Okay, it's fixed now. Like they're very good at what they do, so email them about that. The Tutoring Center is a very, very important resource. If you are struggling, please, 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 I'm hitting my desk as I say this. I'm trying to see if you can hear that. Yeah, it's popping up on my mic. Okay. Please, please, please use the Tutoring Center. Our Tutoring Center is really good. I know some colleges like have underfunded tutoring centers. Ours is not. Ours is super awesome. We specifically have a Chem TA for you. Her name is Candace. She knows everything. She's smarter than me. Go to Candace and tell her I said that. She will save your day. Okay, so we're going to start immediately in chapter 1 and 2 with math. And a lot of 121 students hate math because, I hate math. I don't know how to numbers. And then I tell you how to numbers, and it's different than what you've learned in like high school and stuff like that. And we all freak out. But Canvas will set you right. So if you get stuck early on, don't feel ashamed because you are literally paying for the service. The tutoring center is funded by the college's budget, part of which is paid by your tuition. So you are literally paying for this. And if you leave it on the table, that's no good, right? So the issue might be finding time to go to the tutoring center, but we do have online tutoring available. So clicking on the tutoring center website in the link will help you. The writing center, probably not as helpful for this class because you're not going to be writing lab reports or anything. I just realized that the chat is kind of buried in the back here. Why did this... Sorry, hold on. My chat isn't refreshing. Can I do this? Reload. I'm going to see if this worked. Okay, that sort of works. It wasn't updating, so let me just do this. La-di-da. Test. Okay, that seems to be working now. And then the IT help desk, last link that I have here for you, is in case your password to log into like anything doesn't work, your student email is not working, etc. IT is the second person I would email. If you have like Canvas issues, email e-learning first. Maybe CC the help desk on that too. Or not the help desk, but I'm sorry. Yeah, the IT help desk. Is Candace the only tutor available for chemistry? No. So Candace is the principal one, who is her primary responsibility is chemistry, but we do have other tutors that are in there that are, I think most of them are like students who have passed the class before. So like in the past I've had a bunch of students who've gotten like an A in chemistry who then want to get a job on campus to like earn a little bit of money, and so they get hired by the tutoring center, and then I had to fill out a form that was like, what was their grade, how did they do, are they competent? And I was like, yes, of course they are. I would trust the student to teach another student something. So you may see some of those students in there, and they may even know me, and they may have like good stories or horror stories. I don't know what you'll want to believe, but I can vouch for their ability to do chemistry. So if Candace is occupied because there's like a huge queue or something, the other chemistry faculty, not faculty, I'm sorry, the other chemistry tutors that are present in there are competent and able to help. And I can personally vouch for probably several of them. So at some point you're going to want to read through all of the stuff in the syllabus. For the most part, I am just going to go over the gist of things. So, like, the prerequisites for this class. So, you do have to have completed Math 86 and be eligible for Math 96. So, if you have not taken Math 86 yet, you're going to find the math in this class to be virtually impossible to do without that background. And it's not my place to teach you how to do basic algebra. So, if you can't solve for x and like 5x plus 7 equals 12, my job is not to teach you that. It is to use that to solve other things. And that's what we're going to be doing here. So we're going to just take off running from that point. And if you don't have that foundation, this class is going to be very difficult. And I would strongly recommend that you complete Math 86 before trying to take this class, if you got in here somehow. You are going to need a significant amount of online data. Which means that you will need to have an internet connection, obviously, to see these videos. These videos are archived. You do not need to watch them at the lecture time that is listed. But I recommend that you do so in the event that you have questions, because I can't jump through the computer monitor and answer anything if you're watching the video like 6 hours later or something like that. That is just not a power that has been invested in me. We do have a textbook, so it is General Organic and Biological Chemistry by Stephen H. Stoker. Any edition is fine. You can use the 7th edition. I think the 8th edition is what we have in the bookstore, and we have a custom version that may be slightly cheaper. Of course, it's the bookstore, so they mark shit up all the time. But if you find 6th edition online, 5th edition, whatever, any of that is fine. Is a TI-83 calculator good for this class? A TI-83 will work. It is overkill. It has way more buttons than you need. If you are looking for a budget calculator, you can get a TI-30X2, which actually looks kind of like the calculator I have on the screen here. So this calculator over here. The only functions that you're going to need in this class are going to be some function that does 10 to the x. So like here. Log... And then, I don't know if we do a square root in this class. Obviously, the basic functions, so these guys over here. And parentheses, so those will be important. But I don't think we use E. I don't think we square stuff very often. But yeah, log and 10 to the x we're going to use. And then this is just a quick 10 to the x. So like 5 times 10 to the 2 is 500. So that's what that means. Yeah, you can use Desmos. That works too. The calculator I recommend is Wolfram Alpha, personally, because Desmos is primarily a grapher. You're not going to need to graph your solutions. Everything we're going to do is algebra, and you just type it in a line, and it will just spit out the output. But Wolfram Alpha and Desmos are probably the two best ones. So anything online is allowed. This is not an in-person class, so you're allowed to use any resource available to you. Finally, you're going to need a periodic table. So P-Table is the best site that I know of for an up-to-date periodic table. It has all the information and capabilities that we need. So grab all of those things from the syllabus, then just kind of bookmark them and have them in a folder for like Chem and 121, and you'll be all set. All right. So here's our schedule. Every Tuesday and Thursday, we're going to have a lecture. So Tuesday, 12:20 to 2:10. Thursday, 12:20 to 2:10. Each lecture is 2 hours, as you can see. In the middle of the lecture, I will have a 10-minute break. So we go for about 50 minutes, and then we'll take a 10-minute break. And then we go for 50 minutes, and then we stop. Do try and make it to the lectures if possible. Attendance is not required. But if you miss lecture, you miss out, and that's obviously no good. So, let's see here. You could read through the guidelines later on if you'd like. Let's talk about homework really quickly. So I do not assign homework formally. You're not going to be turning in homework. That is not your carte blanche to just ignore all of the practice problems and worksheets, because that is a ticket for disaster. What you want to do is you want to do as much work as possible to ensure your success. When I get to the part about quizzes, you're going to find out that, hey, I don't monitor, or I don't make you do the honor guard thing. I don't make you take your exam in front of a webcam. I don't even restrict what you can use. You use anything you want online to solve the problems. So that includes the slides. You could watch the video of the lectures during the exam. The issue is you'll run out of time. The exams are strictly timed, so that's your real roadblock, is you need to be able to do all the problems in time. So if you've done your homework and you've organized it well, you just refer back to the problems that you did to see, oh, I did it this way, so here's how I will do this for the exam problem that I'm being given. So do the homework. It helps a lot. Make sure that you ask me any questions you might have for homework or worksheet problems on Discord once we have that set up. I'm happy to help you in any way that I can. You can also just email me questions. All right, so quizzes and exams. So every chapter will have a quiz. All the quizzes are cumulative, which means that I will test you on stuff from earlier chapters, but not exclusively. So you may need to know how to do significant figures for later chapters, but I'm not going to test you strictly on them, for example. Or if we talk about an atom in chapter 2, then in chapter 5, when I ask you about atomic matter or whatever, I'm not going to ask you chapter 2 questions, because it'll be assumed that you understand that. The question types are various, so there may be, like, fill in the blanks. There may be, like, type this answer and then match it with another field, or click on the answer, or multiple choice, or whatever. And I give you the leeway to use any resource you want. So yes, you can make your own notes, and you can use those notes during your exam. So anything I give you and anything that you have available, you can use during the exam. The issue is time. You are going to have a strict time limit for your exams, and if you go and try and look up the answers on the internet, one, it's going to be very tedious to find them, and two, that's going to take a long time, and you won't finish the exam. If you don't finish, the problems that you don't get to are graded as 0. Now, as a further constraint, what I do is I randomize your quiz order, and I give you your questions one at a time, and you are not allowed to backtrack, so you can't just screenshot all the questions, then go look them up, and then quickly type them in. You have one question on the screen at a time. And if you don't answer that question and decide to move on, you get the question wrong and receive no points. So you have to do the questions in the order they are given to you. If you are prepared, that will not be an issue. If you are not, it will. So be mindful of that and have your ducks in a row, as they would say. I give you about 45 minutes for quizzes. Some quizzes are a little bit longer because they have more complex calculations. This is more than enough time to do the quizzes, and the exams are a little bit more crunched. So the intent is that I give you more time on the quizzes, and then by the time you get to the exam, you can do that much faster. Where's the class Discord? So it's not set up yet. I will try and get to that tonight if the invite link has been sent to me. So I think a student is working on that right now. Finally, any quiz or exam in this class you get 2 attempts for. If for any reason you cannot take the quiz on the first attempt, like you're doing the quiz and then like your kid hurts themselves and you have to go attend to them and then your quiz time's out, you get a second attempt. So this is just a thing that I do because I can't account for every possible circumstance. Like your cat throws up. I don't know. My cats throw up all the time. If I was taking a quiz and like I was at the end of my time and I had 3 problems left and my cat threw up, then I would run out of time, right? Because I got to deal with the cat. That's why the extra attempt is there. If you get through the first attempt and you feel like you did fine, you do not need to use the second attempt. That being said, leaving extra attempts on the table, it's up to you. And you do have to have both attempts in before the quiz deadline. We'll talk about deadlines in a second here. There are 2 exam dates. We saw those on the syllabus, and then the final exam is in the schedule at the end too. We have some lab worksheets that I'm going to be assigning over the course of the quarter. We're going to talk about the first one next week. They have various documents that I'm going to upload. Well, I have uploaded, and you will download them and read over them, and then answer a series of questions about them. In those documents are links to videos that I would have you watch, and then you can go over that content and then answer a bunch of questions about it. We'll talk more about that when we get to that next week, but suffice it to say, this is the main thing that you're going to be turning in as, say, homework, is the lab worksheets. These will have due dates. We're going to talk about due dates down here. For any assignment other than the exams or the finals, so this includes quizzes and the labs, I will post a due date for the assignment on Canvas, and this will appear on your calendar in Canvas. So you'll be able to see, oh, quiz number 1 is due on this day. Lab worksheet number 1 is due on this day, etc. Those due dates are soft deadlines. What that means is that I want you to try and get your assignment in by that date. Now, in the past, what I found out is that when I had a hard deadline set on the calendar, half the students would miss it, and then they would all come begging to me, please, can I turn it in? I'm only like an hour late. And I just didn't want to deal with it. So there is a soft deadline, which is printed on the calendar. And then 24 hours after that is a hard deadline. The assignment will close 24 hours after the date shown on your Canvas calendar. It will flag your assignment as late, but I will ignore that. I don't grade assignments with a late penalty. If they are turned in before the assignment closes, it's fine. Okay. So again, calendar date shown on Canvas is going to be your due date. And then if you miss the due date, you have 1 day to turn it in after. It'll be flagged as late, but I don't care. That's fine. If you miss the closing deadline, and I will send out an email that says, last call, I'm closing this assignment tonight at midnight. If you miss the closing deadline, you're done. That's too bad. I do not accept late assignments for any reason past the closing deadline, because I gave you the calendar deadline and I gave you a last call deadline. If you miss both of those, I can't help you. Shit out of luck. That's all I can say. If you have a very, very extreme circumstance that prohibits you from completing an assignment on time, please email me. So if you have like a death in the family, you're in an automobile accident, you're hospitalized, you get COVID, something like that, I need to know so that I can accommodate you. In some cases, I may just advise you that it's time to drop the class. Particularly if you're going to be like in the hospital for 3 weeks, I would not recommend trying to make up the work afterward. It'll just be too much. Down here I have a little paragraph of what's called the Mqa Policy. All of the aforementioned stuff about deadlines and due dates, I allow you to miss something 1 time. If you miss 1 assignment's due date and it closes, you can email me and say, hey, I'm going to use my Mqa Policy claim on this assignment, and I will grade it, no questions asked. Okay? This only applies to things you have not turned in by a deadline. And you can do this for 1 exam. If you have any instance of any problem that requires you to miss something, and you email me and you say, hey, I want to turn in this assignment because I do require you to use the Mqa coupon. Okay, regardless of whether it is because, hey, I overslept and I missed the deadline, or my mother died. Both of those are NQA events that you can turn something in later because they're the first instance. Obviously, one of them is worse than the other. But in the interest of equity, I have to treat them all the same. So if you miss the first assignment for any reason under the sun, I do require you to use your NQA. If you miss a second or third assignment after that and your excuse is strong enough, we'll have to talk about it. I just realized you had a question here. Or is there any case of group work? You are allowed to work with other people, but you are not allowed to turn in duplicate copies of the same work. So you need to do your own assignment. I do check this. If I see people have similar looking assignments, I go through it with a comb. And if they are identical, I forward it to behavioral intervention, and you get a strike on your student record. 2 strikes in this class, and I do fail you. I have kicked students out of the course for plagiarism. So be mindful if you work together that you are doing your own work, because I will be able to tell that, like, oh, these 2 students are working together, but they're clearly doing their own effort. Versus, oh, this is somebody's assignment with somebody else's name on it. So just be mindful of that. I don't think that there's very much else here to talk about. If you have CDS accommodation, make sure you get that in. And then don't cheat. Trust me, I will find out. I absolutely will find out. I have many, many ways to do that, some of which are nefarious and underhanded, and I have caught many students in the tendrils of academic dishonesty before. You do not want to attempt it. Just fair warning. And I'm not just saying that. This is not my first rodeo. I will catch you if you cheat. Learning objectives, nobody cares. You can read about that if you want. That's just what's going on in the class and what you're here for. So, all right. So that's our syllabus. If you have any specific questions about that, I'm happy to address them either in the chat here or over email. Let me know. All right. Now, I have this slide on here about not chapter 1, Chemistry 121. Because a lot of students jump into this class and they're like, I have no idea what I'm doing here. I'm just taking this class because it's required, which is a great reason to be here. Yeah, you have to take this class for your degree. And then they get into the class and they are immediately intimidated for the following reasons. So a lot of students that take this class hate math. I want to put in your mind right now, very, very important. If you are becoming a nurse because you think nurses put everything in the computer and it does it all for them, consider a situation such as like after Hurricane Katrina, where there's no electricity and you're serving as a nurse and there is no computer for you to put the medical dosing information in. You are going to need to know how to do math. Hands down, if you do not want to ever do math, do not become a nurse. Hard stop. You are going to need to get over that fear. And my job is to help you get past that. Math is scary at first, but if you do enough of it, like anything, you can learn to do it. Math is difficult and scary, just like skydiving or scuba diving is scary at first, but eventually you acclimate to it because you have enough practice, okay? So don't be terrified of symbolic logic. Are you able to use notes and or resources on the exams or just the quizzes? Yep, you can use it on anything you want. I don't monitor your quizzes or exams. The way that I restrict you is your time limit. So I do make the time limit progressively shorter on more difficult things. The final you have to do very fast, relatively speaking. I think you get like 2 hours and 10 minutes to do something that is the equivalent of 2 exams. So if you can't do it in that time, it's because you haven't been practicing enough, is my intent. The next thing that this class requires you to do is critical thinking stuff. So what that means is word problems. You are not going to see problems in the field, we'll say, that are like, if 2x plus y equals 4, what is x plus y equals 6? And then if you don't answer it in time, the patient dies. That's not how the world works. What you're going to see is a patient's chart that has their weight, the requested medication, and there's going to be a box for dosage that you're going to have to pencil in, and then send it up to the laboratory to administer or get that dosage metered out for you, or whatever. So you are going to have to take context into consideration and sift through the information that is available to take out what you want and ignore the rest of it. For example, you don't really care about the patient's height, probably, if you're going to dose them with medication. Nor do you care about their name or their age. Maybe their age matters. Or their preferred pronouns, or their I'm trying to think of other things that would be on like a medical sheet. A lot of those don't matter when administering medication. Like, you just need to know very specific things to know, okay, this is how much I give you. And so you're going to have to know what to look for in specific problems. We're going to do some of those types of problems in this class. And then finally, there's just some stuff that you want to have on hand. And so things like, what is phosphate? Or what does it mean if a molecule is tetrahedral? Or what is the electron cloud around an atom? There are specific concepts that you are going to want to know and understand what those things mean, just rote, sort of, for this class. So that can be intimidating, and that is a lot that I'm going to ask of you. So this is a complex class in the sense that there is a lot of stuff that you're going to need to know over the course of the entire quarter. What can you personally do to prepare? Well, we've already mentioned this a little bit here. And so we've actually taken a survey from students who have completed Chem 121. And this is not just my class. I mean, this is just Chem 121 students from not just in our department here, but like across the state and all over. Chem 121, people take this class everywhere. This is offered at every community college under the sun that I'm aware of. And what they found was that if you studied 2 hours per day, the grade that you would expect to earn for an average student is C. Now, obviously, you're not here to get a C, I would assume. At least not yet. Maybe towards the end of the quarter, you'd be like, you know what, a C is fine. I just don't want to deal with this shit anymore. But right now, everybody wants to get an A. If you are an average student, you're going to have to put in more than 2 hours per day to get an A, which means a lot of hard work and time. And so that's going to be things like doing anything from the textbook. Sapling we don't use anymore, so that shouldn't be there. Doing the worksheet problems, etc. Just reading the textbook, or doing other things with your time that are tangentially related to the class. So, for example, in the class Discord, you might have a study group. You might form a study group and use the voice chat in there to talk to other students. Or you might just have an email group or another method that you work together with. Or you might actually meet at a coffee shop. Any of those work. The more time you spend on this class, the better. And you're going to notice that I say that a lot during this quarter. Where is your time? How much time have you been spending on this? Do you have the time? If you're in Chem 161, come back in about 2 hours at 2:30. And then we'll do Chem 161. This is Chem 121. So, depending on your study habits and other life concerns, you may need more or less time than this. For example, if you are working 40 hours a week and taking this class, you're going to have to find time to study. That might be time at work, depending on your job. So, if you're working in, retail, there might be slow moments, where you can actually do, some exercises. Nobody's in the shop right now. I can do some practice problems. When I was working at a gas station in high school, overnight, I could have done practice exercises if it wasn't summer and there was homework to do. Because I didn't get customers all the time at 2 a.m. Other jobs, that is just not possible because you are maybe you're in construction or you work at Amazon or something like that. You don't have a second to rest, so that's not going to work for you. And when you get home, you're going to be fucking tired. You're going to be so exhausted. So be very mindful of, do I have enough time for this? Because I personally think that every student can take this class and be successful at it. The thing that is going to stop you personally is time. Do you have the time to be successful in Chem 121? Because if you're getting a D or an F, it's not because you suck. It's because you don't have time. If you had more time, you could prepare better and get a higher score. Because remember, the more you practice something, the better you get at it. Nobody started cooking on their first time and was like, look at this quiche I made. It's fantastic. Or this filet mignon. I'm so good at cooking. It's my first time in the kitchen. No, you burnt the shit out of whatever you were working on, or you didn't cook it enough and it was raw and it was terrible and nobody wanted to eat it, right? Including yourself. That was how my first time cooking went. But you get better at cooking as you go. And now I'm actually a very good cook. But it's taken me years to get there. I couldn't get there if I didn't put in any time. Okay? So in this class, don't get discouraged if you are struggling. What that just means is that you have to put more time in. Okay? This is a 5-credit course. A 5-credit course is nearly half of what we consider a student's full-time load. So a full-time student should work 12 credits, which is the equivalent of a 40-hour work week. So if you are working 40 hours a week and you're taking 12 credits, which is worth 40 hours of work, you are basically doing the equivalent of an 80-hour work week. And if you get stressed out after like 1 or 2 weeks of that, it's no wonder. You're working an 80-hour week. That's ridiculous. So please be mindful of that. Make sure you are not signed up for this class and have too much on your plate. And then if you do continue with the class, make sure that you are in a situation where you have enough support in terms of time and resources, excuse me, that you won't get overwhelmed and then sink. Because that's the worst thing for me to see at the end of the quarter, is like seeing all my students who I was like, I know the student could pass, they just don't have enough time. So finally, here are my study and hint advice for what you should do to get through this. So don't miss any lectures. Try and be here on time. I have found that students who show up to these lectures, far and large, have a much higher chance of passing the class than those who just watch the videos afterward. If you have to watch a video afterward once or twice a quarter, or like maybe you can make the Tuesday one, but you can't make the Thursday one, that's probably better. You'll probably be okay. But if you fall behind and you have to watch like 6 videos before you take the exam, you're not going to make it because you're not going to have time. So be very careful. Make sure that you have enough time to manage with this class. Do as much of the work as you can before you do the quizzes or the exams. If you have done the practice problems, you will be in much better shape for the quizzes. What I mean is do that a few days in advance because your brain needs time to process and digest stuff. Cannot emphasize this one enough. Find other people in the class and form a study group. If you have friends who are working together with you, you can find each other's strengths and weaknesses and help build upon those. So maybe, for example, you are really good at math, but you really struggle with like how to make ionic compounds or something. And your study buddy is the opposite. They're great at figuring out the conceptual stuff, but they're not very great at math. If you teach someone something, you become better at it. If somebody teaches you something, they are gaining from that practice. So it is in your interest to work together and teach each other. I am teaching you because it's my profession. This is what I do. But by doing this, I actually do get better at teaching you this content. I knew all of this stuff the first year I taught, but I'm a much better instructor now that I'm in year 11 than I was in year 2. And that's just sort of how teaching works. So if you can get into a position where you can help somebody out by like, oh, this is what I did to solve this problem, and this is how I know the solution, you will learn so much more from that, believe it or not. It's this sort of learning that goes on in the background. The last thing that I would recommend is that when you are preparing for a test or a quiz or something, what you want to do is do practice with like a timer in the background. Set a timer for like 6 minutes and see if you can solve a problem. Now, this slide in particular is engineered for in-person classes where I don't allow the use of notes or anything on exams. But in this online class, you do get to use your online notes. You get to use any materials that you want. any resources that you want. But if you want to make sure that you understand the problems, try and solve the problems without any sort of notes or assistance. You can always use a calculator, and you can always use a periodic table. Is the screen fuzzy? So the way that you want to manage that is that, let's see here. Okay, so right below this 0 right here that I have hovered over, if you go straight down, put your mouse there, and you should see a little gear icon on the screen. If you click the gear icon, it'll say quality. Set the quality to 1080p 60. It'll buffer for a bit, but it'll clear that up. So it probably just set your resolution to a low bit rate because your internet like crapped out or something. So if everything is fuzzy, that's how you fix that. My last recommendation is please talk to me. A lot of times students get frustrated and then they just ignore me. Don't do that. If you start to fall behind, try and talk to me. Ask me questions on Discord. Ask me questions over email, and I'm happy to answer them. Anything that like is a problem that I can work out or write out for you, I can just paste in Discord. Because I have, you're going to see this right here in a second here. So I have this screen right here. This is my whiteboard. It's really just Photoshop. And I can basically do whatever I want to on here. So we can solve any problem because I'm just going to write all over it like a whiteboard. So all of the answers will be here. There's my handwriting. So we'll just get rid of that. We'll go back to here. And I believe that that's everything. All right. I'm going to have you guys talk to each other if you want to for a little while, because we're going to take our break, and then we're going to get started on Chapter 1. So when we come back from our break here... Oops, I don't have a timer up. Let me get that real quick. Every hour we take a 10-minute break because this is a union job. And also, I find that you guys go kind of glaze over after 50 minutes if I don't. So I'm going to start playing the music. Our soundtrack this week is Tunic, which just came out like a month ago. The music is beautiful, and I love this game so much. So please enjoy that. I'm going to start the timer, and we'll see you in 10 minutes. right, we are back. Let me wind this down here. So we're having a conversation about music in the chat. So I listen to a lot of different video game music. A lot of it I can get away with playing on here because it's for small games and such, or old games. I mean, I've tried doing Final Fantasy music in the past, and that's generally gotten a lot of notifications. Not strikes. I've never gotten a strike on the channel, thankfully. So I do what I can to play various and diverse music, because there's a lot of really good music out there from video games. All right, so we're going to start with Chapter 1. So, oops, it didn't actually advance here. There we go. Chapter 1 is all about matter and why it matters. So, matter is the stuff that is around you. What does that mean? Well, if you, like, pat your table or your chair or your head... Oh, that actually... Oh, because I hit the headset. All of that is made of matter. And what we're going to discuss in the first chapter is various ways that we can both interpret what matter is, how we can sort matter, how we can interact with matter, and how we can label it so that we can refer to it later. On the screen, you're going to see 3 different pictures of things. I have a bowling ball, a cup of coffee, and an orc. All of these have 2 things in common in terms of their physical makeup. One is that they all occupy a space. Any space occupied by an object cannot be simultaneously occupied by some other object. I cannot occupy the same space as another person. If I tried to do that, I would displace them. What textbook do you need? It's in the syllabus, or rewind to earlier in the video when we went over that. Secondly, each object has mass. What that means is that if you were to stand on a scale, it would register a number that wasn't 0. So I could put each of these objects on a balance or a scale, and they would weigh something. So those 2 properties together create a definition for something that we call matter. So anything that has 2 of these 2 properties, we're going to call matter. So people... I'm looking at things on my desk. My tablet, my keyboard, this can of polar seltzer, this statue of an orc from Shadowrun, this calculator, this phone, this set of dice for D&D. These are all examples of matter. Now, what wouldn't be matter? What would be an example of something that isn't matter? That would be something like sound. For instance, my voice coming through your speaker or headset or whatever does not have a mass to it. You cannot weigh my voice, right? But it's clearly interacting with you. So it must be something other than matter. Typically, that's going to be something we will call energy. Will we need the textbook on class days? It's up to you if you want to use the textbook to follow along. I'm not going to strictly use the textbook for... like, go and do problem 17 in your textbook. I will put that on the screen because I can't assure that everybody has the textbook yet, or has it readily available. It's strictly for your use outside of the class period, but we might refer to it. All right. Now, chemistry, i.e. the whole point that we are in this class for, is the study of how matter interacts with other matter. So if I sit on my chair... will my chair react with my clothing? If it does, that's bad, right? Likewise, if I take this medicine, will the matter interact or do something to my body? If it does, and that result is desirable, then that's good. Maybe I'm taking medication to inhibit a... like some sort of receptor, and so I feel better about myself and I stay more focused. Like ADHD medication or something like that. That would be a positive outcome from chemistry. Likewise, a negative outcome would be that I drink something and then I explode. Because what I drank was like trinitrotoluene and it detonated in my belly. That would be bad, right? So not only do we care about how matter does transform stuff, we care about why it would not do that. And so we're going to have various times and cases where, hey, we want to know why this reacts, and we want it to react, versus, oh, we don't want a reaction. We're going to look at 3 primary phases in this class when we're talking about matter. As we progress through the quarter, we're going to be looking at different ones in context. We're going to spend some time looking at gases independently. We're going to be working mostly with solids and liquids. Here are the definitions of those things. We are going to define them in terms of both their shape and their volume. I want to underline these. So shape and volume. The shape of something is what outline you could draw on it in space. So for example, this sphere that I have here, it's hard to draw from my perspective here. I'm drawing to my left, but I'm looking to the right, so I'm not actually looking at what I'm drawing. So I outlined this ball in red. That would be its shape. Whereas the volume of something, and we'll get a different color for this. The volume of something is what amount of space it takes up in some unit. So, for example, milliliters is a good unit of volume. Gallons is a unit of volume. Things like that. We'll talk about units in Chapter 2. But the gist of this is, how do shape and volume interact with each other? For a solid, my shape is fixed. I cannot change the shape of a solid most of the time. If you take like a calculator or a book and you push down on it, its shape will stay roughly the same. If something is the same shape, then its volume must not change at all. And therefore, we would say that shape and volume are fixed. So what we're going to do is we're going to go over to this page here. And we'll just have each of these on the screen. We'll just start here. And so I'm going to make a little table here. So we're going to say shape, volume. There we go. And then we'll go whoop. All right. So for a solid, we said that the shape was fixed, i.e. it's rigid, you cannot change it. And as a result of that, the volume would be fixed as well. Now up here, for my liquid, we'll put the definition of the liquid up there. So if I had a liquid, and I had a liquid that was, say, 1 gallon. So let's suppose that I have, like, a jug here. And there's the handle. And it's mostly full. So I have a 1 gallon jug. The shape of this liquid would be what I'm outlining in black here, with that excluded, right? So there's the shape of it. Now let's suppose I pour it on the ground. Now its shape would be just a puddle on the ground, right? But its volume would still be 1 gallon. It's just now spread out over a large area, right? So liquids have an interesting property. They adapt the shape of their container. So the shape that they occupy can be whatever the shape is of their container. But the volume that they occupy is based on how much liquid there is. So you can see that we could define a solid and a liquid differently by this nature. And then for gases, on the screen there, you can see I have chlorine gas in a container. So, oops, that's not the, there we go. Oop. So if I had a balloon, there we go. And my balloon has gas in it. Then this would have a specific shape and volume. But if I then transform the balloon's shape by, like, say, compressing it, hold on. There we go. Where am I in here? There we go. I'll just do that every few minutes if I have to. Let's see here. So if I change the balloon shape by, like, say, compressing it, then the shape will change, but so will its volume. And so for gases, you will notice that we have a variable shape and a variable volume. They strictly adapt the shape and dimensions of their container. And depending on what your container is, you will have a unique shape or volume. All right. So now that we know what the different phases are of matter, what can we do with these definitions? How can we manipulate matter so that we can understand how it interacts with other things and also define it in a more useful way? On the screen, I have a bunch of different ways where I can interact with some sort of matter. So for our purposes, let's just assume that it's like paper or maybe something like, I don't know, cloth or something like that. So if I heat something enough, I might cause it to melt or like deteriorate in some way. But if I heat other objects, I might cause them to just burst into flames. What if I drop something in a liquid? For example, if I drop table salt in liquid, it'll dissolve. If I drop like paper in liquid, it'll sort of start to fall apart. If I drop like cloth in liquid, it doesn't really do anything. It just gets wet. You may or may not be able to recover the object based on its exposure to the liquid. You can measure various properties of certain things. Using tools, for example, like a balance or a ruler or whatever. Some of these actions that you will take will change the identity of the matter, and it'll be almost irreversible. For example, your matter will turn from we'll call it A into B, but you can't transform it back from B into A, at least not easily. And then other actions that you do won't affect it at all. You'll start with paper and then you'll end with paper after you've done the thing that you are doing to it. We're going to use this as our guide for this section. So our objective here is to figure out what actions fit into these two categories. What changes my matter irreversibly and what changes it in a way that is negligible. So let's define some more terms here. A property of matter is going to be any characteristic that is unique to that matter. You can use that property to discern it from other things. So, for example, water is a liquid at room temperature. There are not a ton of liquids at room temperature. You could probably think of a few, so like gasoline or lighter fluid or acetone. But you could use that description to define and discern those from other things, such as like plastic. Plastic is not a liquid at room temperature. Concrete is not a liquid at room temperature. Soil is not a liquid at room temperature. Things like that. And so these are all examples of different properties that you can make. You can make a property out of anything that you want to. Now we're going to define a change as any sort of action that causes matter to change. Like, duh, right? So, for example, if I have ice and I leave it out, it will melt into liquid water. The change that occurs here is the melting. If I have bread and I put it on the countertop and I don't put it in the fridge or I just leave it there forever, it will get moldy. The change that occurs is it gets moldy. Iron will rust when exposed to water vapor and air. The change that occurs here is rusting. We are going to impose changes upon matter, and then based on the result, we're going to identify that as either a chemical change or a physical change. A chemical change will change the identity of the matter, because we've done chemistry, it's transformed the matter. A physical change will do physics to the matter, which means that we haven't changed it in any meaningful way at the atomic level. We have just manipulated it somehow, and its identity was preserved in the process. Excuse me, I had to cough there. All right, so there's our rubric. It's on the screen. I'm going to put an action in the arrow for a given situation, and then we are going to compare before and after what the stuff is that we're looking at. Now, this is not a trivial thing to do at this point in the class, it turns out, because what our rubric is going to refer to is the chemical formula of our substance. What is the chemical formula of something? It is the elemental representation that we're going to start to learn to write out as we go through this class. For example, we all know that water is H2O, because you've heard that before, right? You don't need to be in chemistry or have any chemical background to have heard H2O before. You've probably also heard oxygen is O2. Like, these are very common chemical formulas. If I give you a substance and I say, what's its chemical formula? A lot of the time you're going to be like, I don't really know. Like, what is the chemical formula for gunpowder? Or benzene? Or paper? Like, these are all objects that you could interact with. But we don't know their chemical formulas without looking them up. And if you have to look them up, that's totally fine. You can do that if you'd like. However, if you don't know something, you can still use your intuition to solve these types of problems. And we're going to develop this intuition as we go through more exercises and we do more content in this course. What we're going to do is we're going to look at these two types of changes and try and intuit the chemical formula for the substances involved. And we're going to try and keep it fairly easy. For a physical change to occur, the formula of before and after needs to be the same. So the example that I have here is ice. Ice is just frozen water. Ice is H2O in the solid state. But if I allow my ice to melt and become water, then it becomes water in the liquid state. The formula is the same, it's just the molecules are arranged in a different sort of state. We're going to define this as a physical change because I still have water both before and after. Now, any phase change is going to follow this sort of pattern. So if I go from solid to liquid or liquid to gas, then what ends up happening is that I keep my molecules in their same sort of nature. Their formula is the same. But how they are arranged relative to each other has changed. So in a solid, all of our molecules are aligned in like a rigid structure. In a liquid, they can move around. But all the molecules are still what they were before. They can just move now, right? So a phase change is going to be a physical transformation. If you ever see a phase change, regardless of the substance that you're looking at, it went from a solid to a liquid, or it went from a liquid to a gas, it started boiling, or it condensed. Any of those things, totally fine, before and after in terms of the formula. Nothing has changed. And so we're going to define that as a physical change. Other physical changes are going to be things like if you manipulate an object, but you don't do any obvious chemistry to it. So for example, on the next page I have tearing paper. Right here. So this is very obviously a physical change because it's still paper before and after. If I tear up the paper, all I'm really doing is changing its size. And by doing that, I'm just making smaller pieces of paper that are all functionally equivalent, right? I could treat the paper as for whatever I need to do with it. So I could write on the paper, I could fold the paper, etc. It still behaves the same. You can do that even though you don't really know what the formula for paper is. So using your intuition, you can infer which changes should be physical. For example, if I pour water into a smaller cup, it's still water. If I pour gasoline into a smaller cup, it's still gasoline, even though I may not know the formula for gasoline. Now, when do chemical changes happen? These happen when you have some sort of obvious transformation that has occurred. So, for example, if I set paper on fire, if I try and look at paper before and after, I could write on paper and like write my name on it. I could draw a picture. I could fold it into like a paper plane. But if you set it on fire and you try and do the same thing after, the result that you get is very, very different, right? You cannot write on ashes. You can't fold them. You can't use them for the same things that you'd use paper for. They have very, very different properties. Furthermore, there is not much that you can do to turn the ashes back into paper. So if you have difficulty reversing the change, then what you have seen is a chemical change. And so let's write that down here too. So if it's easy to reverse the action, then the change that you are looking at is most likely physical in nature. If the change is very difficult or it seems impossible to you to be able to undo this, so like turning ashes back into paper, very, very difficult to do that. You probably can't think of a way to do that. I can, and it involves you planting the ashes in the ground, planting a tree, the tree absorbing those nutrients, and then we cut the tree down and turn it back into paper. That's a very roundabout way to do that, but we can totally do it if we need to. I would personally categorize that as difficult, so the initial process of turning paper into ashes must be a chemical change. So that is your rubric. Look at the formula before and after. Try and consider how easy it is to reverse the action. Or use your intuition and common sense. Like, oh, did I do this thing to it? Is it still the same as it was before? Now, because this is a chemistry class, we are going to be doing chemistry, and we're going to be looking at chemical changes. We're going to start with stuff, and then we are going to end with things that are unique to what we started with. And the things after will have unique properties compared to the stuff before. For example, aluminum can be corroded pretty easily. However, aluminum oxide is very resistant to chemical corrosion. So your aluminum can is coated with a thin layer of aluminum oxide so that the acidic nature of, say, like a soft drink does not dissolve the aluminum into the solution. And then when you drink from it, all you taste is aluminum can, which is also not very healthy for you. So we're going to study a bunch of different types of chemical reactions in this class, and we're going to be mostly focused on chemical changes later on, but we do care about physical properties and changes because they are common enough. All right, so this is our first practice problem set. What I want you to do is I want you to type in the chat. I probably should do this. Oh, now it's just filled with that. Okay, well, I guess that's just going to stay on the chat list. Okay. What I want you to do is in the chat, I want you to type your answer to each of these, and I'm just going to count these down here. So do I have the pen? Yeah, I do. 1, 2, 3. So for each of these 8 problems, what I want you to do is tell me, is the action that I am doing physical or chemical in nature, based on the description that you see there. So type in the chat like 1 is physical, 2 is chemical, or whatever. You could talk about it with other students if you'd like. However you want to do it. I'm going to give you about 3 or 4 minutes to do this, and I'm going to just hit mute. And you can go ahead and answer these right now, and we'll go over the answers when I get back. So see you in a bit. All right, one more minute. We'll go over the answers here. All right, let's go over the answers here. So for number 1, I have... Oops. Sorry, I'm moving windows around because I'm doing a bunch of things in the background. There we go. For number 1, I have delicious pasta, and I put it in water that is boiling. So the action here would be boiling my water, and so that would make this physical in nature. For number 2, all I'm doing is looking at my soda, right? If I'm looking at the soda, I can't be changing its nature in any way, right? So this would also be a physical action. No change is occurring, but this would still be a physical sort of interaction with the soda. More specifically, what is instead happening is we are interacting with the soda with light. So light is being absorbed by the soda, and then it is being emitted or reflected off of the soda to our eyes, which we then see. So everything that we do actually interacts with matter in some way. But this interaction is physical in nature. It does not change the soda. Now, Alka-Seltzer is dissolved in water. You might think, oh, it dissolved. That's an interesting word, but be careful when you see the word dissolved. Because dissolved just means it dissociates into pieces or is hydrated with water, if it doesn't do that actually. Like, for example, carbon dioxide can dissolve in water. What we actually want to note here, let me do this, is this one. Does Alka-Seltzer normally release a gas? By itself, no, right? How about water? Does water normally release gas? No. Water is very just water. But if I put them together, it starts bubbling and fizzing immediately. So it must be the combination of these two substances that causes some sort of change that results in a gas being released. And so this would be a chemical change. So what do I mean by action again? An action is anything you can do that involves matter. So me looking at matter technically involves it because of the light definition. Light bouncing off of the matter and then to your eye receptors in your retina. Or if I like touch the matter to observe that it is firm or soft. Like Jello is soft, and I could determine that by poking it. But me poking the Jello doesn't change it into something else. It's still Jello, so that'd be a physical thing. If you like fluff a pillow or a cushion, you are like smacking it or changing its shape. I don't have a cushion next to me to do that to make the right sound, but it would still be a cushion when you're done with it. So those are actions that you can take that don't seem like chemistry because they're not. Number 4, sodium metal is melted. We said that any phase change is physical. So sodium metal, even though we don't really encounter sodium metal that often, we identify it in a different way. That is a physical transformation in that nature. Number 5, the gunpowder in a bullet is ignited. If you ignite gunpowder, you create an explosion or bang. But if you try and do that a second time, you can't do that because the gunpowder has already been reacted. You cannot react gunpowder over and over and over again. Furthermore, you can't turn used gunpowder into unused gunpowder very easily. So this must be a chemical reaction. Number 6, air is compressed in a scuba tank. If you compress air, you are making it occupy a smaller volume. And that is the only change you're doing to it. Number 7 is also physical because... Oh, oops, I forgot to underline these words here. So, if you whittle something, you are basically cutting away pieces of wood to change the shape of an object. And in doing that, it's still made of wood. My grandmother's sister, which I guess would make her my great-aunt. I don't know. I didn't really interact with her very much growing up. Ooh, let me... My power just flickered, and I didn't like that. She was a woodworker, and she would carve all these, like, bunnies and, like, squirrels and random woodlands creatures out of wood, and it's really cool. But what you have at the end of the day is still wood, right? If it caught on fire, it would burn like any other piece of wood, and that'd be a shame because someone put a lot of work into that. Finally, this last one, combustion is a special reaction that we're going to talk about in like chapter 8 or 9. When you combust something, you react it with oxygen to produce energy, carbon dioxide, and water. When you combust gasoline, you get exhaust products and water vapor, and you do not get the gasoline back easily. In fact, the easiest way for us to get gasoline is for us to just go to the pump and get more, right? Now, if it caught on fire, the wood would be chemical. The wood would. So burning wood is a chemical change, yes. Oh, I didn't write it down here, though, so sorry. Chemical. At the end of each of these sections that we're going to do, you're going to see a series of problems. This is the recommended practice that I have for you out of the textbook. So I would say use your textbook to do problems 1 through 22 as an exercise to prepare you for the quiz. Generally speaking, I do recommend that you do every problem, but I don't assign every problem all the time. If I don't assign certain problems, it is because I feel they're beyond the scope of this class or whatever. I won't test you on those problems that are omitted. So just FYI. FYI. Am I going to make that as an announcement on Canvas? No? I'm sorry, I'm confused. What announcement were you referring to? Do you mean the homework problems that are on the slides? They're on the slides, so I don't make announcements for things that I have already given you. If that's what you meant. Sorry. Yeah, no, the homework problems are on your slides, and you have these slides, so you can download these slides from Canvas. They are available for you, and the homework should be listed at the bottom of them. All right, we have one more thing we're going to do today. We're going to classify matter. On the screen, I have two substances. I have water and cake. If you were going to classify one of these substances as pure, which one would it be? Now, I'm actually hoping that you will type in pure cake, because if you know where to get pure cake, I would love that. That sounds great. But no, that's not a thing that exists, right? Yeah, everybody's typing water. Because that's the thing you can have pure. You can have pure water, That just means that there's only water in there. But pure cake doesn't make sense because cake is a mixture of various things. In this case, it would be flour, eggs, sugar, chocolate, obviously, cherries, and all sorts of deliciousness. As much as we want pure cake, it is not a thing. So that's going to be our rubric that we're going to use to define for this section here is something pure? Is there only one thing in it, one form of matter? If something has multiple different substances available, we're going to call it a mixture. So cake is a mixture, but water is a pure substance. There's only one thing in water, it is H2O. Now, pragmatically speaking, if I was going to classify something as pure, it would be virtually impossible in the real world. For example, if I give you tap water, there's going to be stuff in your tap water, right? Like there's a little bit of fluorine in there because our water's fluorinated. There's probably a little bit of like trace elements of like iron or calcium and magnesium. Heck, there's probably trace lead and mercury in your water and arsenic. Trace meaning like a very, very, very small amount. Is it enough to hurt you? Almost certainly not. But is it zero and therefore not a mixture? The answer to that is no. For the purposes of this class, we are going to consider all of these substances as ideal. So ideally, the water on the screen would be pure because I have not mentioned that there's anything else in there. Okay? So I am not intending to trick you with these questions by saying, I have a balloon filled with oxygen. And then you say, oh, it's pure. And they go, haha, it's a mixture. There was actually an argon atom in there. Like, no, there's no way you would know that. So base your definition of whether it is pure or a mixture off of the context of the problem and assume that only the things that are written are there. Now, if I give you something that is obviously a mixture, so for example, I say, gosh, I'm trying to think of an example of a mixture that would be food related. Chili powder is what I'm coming up with. I don't know why I thought of chili powder. I guess I really just want chili. But like if I said chili powder, there's obviously multiple things in there. Like right, there's the capsaicin, there is the cumin, there is the paprika, there are all sorts of things. Like there's different ingredients. So it must be a mixture. A cheeseburger could be a good mixture. I just wasn't thinking of a cheeseburger. I had Mexican food last night and it was fantastic. And now I just want to eat Mexican food all the time, I guess. I'm from California, so. Even things like the Higgs boson, that's difficult to define in this sort of context because we're not really doing chemistry with Higgs bosons. So I can't really explain that in this context or at all, really. Wes, please, I haven't eaten lunch. I know, neither have I. I'm not going to get to eat until 5. So I had a very brief snack before class. I'm going to go eat candy in the 30 minutes between classes. And that's going to have to tide me over. All right, so there's our first decision point on this tree. Does the substance contain only one, or does the matter contain only one substance? If yes, it's pure. If not, it's a mixture. All right, I'm going to just put all the text on the screen here. These two substances are pure substances. However, is there a way you can print the slides out? Yeah, you could just print the PDF. You can download the slides from Canvas. So if you have access to the modules tab, you can download all of the slides. I allow you to print them. Now on the slide here, these two substances are considered pure because they contain only one thing, but the number of elements that are present in them is different. For example, diamond is made entirely of carbon. Carbon is one of the elements on the periodic table. And so that's where we're going to go to P table here. And we'll put that on the screen really quick. Oops. I only really want the table here. All right. So this is the link that I gave you guys earlier to ptable. Let me move that off the chat here. So if you email me again, I can send you the slides. I can't obviously do it right now because I'm in the middle of a lecture. But when you are enrolled in the class, you will have access to all of those things. On the periodic table here, I have... Oh, I guess I don't need this down at the bottom either. I have all the different elements that are available for us to make matter out of. If I have only one element involved in my substance, we're just going to call the matter that. It is an element. So, for example, diamond has only carbon, so we're going to call it an element, because the only element present is carbon. Now, table salt contains two different elements. It contains sodium and chlorine. Putting those two elements together in a certain pattern creates table salt. However, the table salt is still a pure substance because there is only table salt in the salt shaker. So that means that all of the elements in that salt shaker are combined in pairs to make a unit that we would call table salt. An Na and a Cl unit together forms table salt. And then you just have tons of those pairs. It'd be the same with water. Water is H2O, where you have each molecule of water has two H's and an O. And then you just duplicate that over and over and over again. They're all identical. Same with table salt. All the NaCl pairs are identical. We're going to call anything that has multiple elements in it, but is otherwise pure, a compound. So when we look at pure substances, we're going to look at the chemical formula and identify, is it a pure substance or a mixture? Or not pure substance or mixture. If it's a pure substance, is it an element or a compound? We'll deal with mixture in a second. And the way that we determine that is how many elements are present. One is just element, two or more is compound. Over on the mixture side of the diagram that we have, we can split mixtures into two categories as well. And so what we're going to do is we're going to use the following rubric. I am going to circle different portions of our substance. Now, the circle at the bottom is supposed to be inside the container, so I am ignoring the fact that there is a ceramic bin or paper, or whatever that is, for our ketchup. Every place that I circled will have ketchup that should be indistinguishable to our senses. So if you taste ketchup from the top of the container versus the bottom of the container versus the middle, they should all taste the same, provided that you have mixed the ketchup well, you're doing it all in one sitting, you haven't let it sit out, etc. If all the portions are indistinguishable to your senses, we're going to call that a homogeneous mixture. So an example like soda pop, or any carbonated beverage, really, is a homogeneous mixture. If you drink the entire thing, the first sip and the last sip should taste indistinguishable to your senses. Now, if you drink some now and then you drink it later, it will change over time because different processes are happening and chemistry is involved in that. So compounds are pure. Yes, compounds are pure. So water is a compound, and we did say pure water, so compounds are pure. They have only one type of substance in them. That substance just happens to have multiple elements. So here our ketchup is homogeneous because every portion we take is identical. Down here in the salad dressing, if I take a portion off of the top, I get mostly oil. If I take a portion on the bottom, I get something very different. I get all the herbs and spices and then the water part, right? Now, in salad dressing, you want both things, because they're both delicious. They're all really tasty together. However, you have to mix it to do that, and it does eventually separate. So, in this case, because we have different phases present, we have different portions that are not indistinguishable, We would call this heterogeneous. Another example of something that could be heterogeneous would be something like pizza. If you eat pizza, the first few bites are from like the pointy end, right? The part that's in the center of the pizza. And those taste good. But then if you turn the piece around and you eat the crust tastes very different because there's no toppings there, right? Because you have different portions of your food there, they are not the same. All the portions are not identical. So pizza would be heterogeneous. Now, again, we're going to try and make these differences obvious in the terms of like the problems that I'm going to give you. So I'm not going to give you something like blood, which is technically heterogeneous because you can separate out the plasma from the blood. But a heterogeneous bloodstream in your body would obviously be very bad, right? So you don't want your blood to like clot out in different places. Heterogeneous mixtures in your bloodstream would not be ideal. So I'm going to try and keep it very simple. Here is our completed flowchart because we're almost out of time here. I want to get through this. And then I have another flowchart which just has more examples of these substances. From the first textbook that I ever taught from, I actually went and scanned this picture, which is why there's that little scanned thing down at the bottom there. All right, so that's all that we have time for today. I'm going to put this up on the screen for you to try. We're going to start lecture from this point on Thursday, where we talk about these examples. I'm going to have you try them then. But there's the homework practice for this section. And that's all I have. So I do want to thank everybody for coming out to the lecture here. I hope that you find it useful. Make sure that if you have any questions that you email me. I did see that somebody sent me the invite link for the class Discord, so I'm going to go set that up probably after my other class today ends at like 4:30. But until then, make sure that you do as much practice as you can on the stuff that we've covered. Don't fall behind because this will go, you blink and you'll miss it. This quarter will go pretty quickly. Okay? That's all I got. Have a wonderful rest of your day. We'll see you again on Thursday, and take care.